is positive bias clamper or positive clamper circuit with some reference voltage. How does the circuit appear? Diode is directed upwards. It's a positive clamper for which I am adding some reference voltage, V reference. Capacitor, V input and V output. What might be the output here? Just simply we know what happens across the diode. Actually here I am writing VD from cathode to anode, right? To be frank, voltage across the diode means most of the times we deal with anode to cathode voltage only. Okay, doesn't matter, it is our, for the sake of our convenience I am doing it, so doesn't matter. V output is equal to VD plus V reference. What is VD, friends? We know VD is equal to Vm sin omega t plus Vm, for which we need to add V reference. That's it. Very, very simple thing. From the previous knowledge or what we have seen so far, based on that I am directly writing the answer here. Okay. And how about the output waveform? If you see the output waveform, V reference, we can see the output something like this. It is Vm plus V reference to Vm plus V reference. That's it. This is how we can see the response of this positive biased clamper. Okay, let us have a look at how these things are coming. Writing the answers is very simple, but if you see the analysis, you will understand how much typical points are involved in this. See that. Just as an example, I am taking here reference voltage of 2 volts and input is 5 sin omega t. V capacitor, I am taking polarities like this. Anyway, VD is this way and V output. We know that V input is equal to V capacitor plus V output. Also, V output is equal to VD plus 2 volts. Okay, all these things are well known to us. Then, the input sine wave. V capacitor. Here I kept a reference voltage of 2 volts. Okay. This is 2 volts. I am just taking some time intervals. And output equation, right, output wave shape or waveform I am writing in the next space, as given space is not sufficient. Here for capacitor voltage I will do one thing. This is much better. Okay. Now let me take this instant as t is equal to 0. So initially the capacitor is uncharged. I am starting with an assumption that 0 initial conditions. That is, we voltage across the capacitor at t is equal to 0 is 0. That's what it means. Okay. Then when you apply the input for at t is equal to 0, what happens? Right, the diode starts conducting because the cathode of the diode is at 0 volts and anode is at 2 volts. So cathode is at lesser voltage compared to anode. So 0 to T1 I can write 0 to T1 input is less than 2 volts and hence the diode will definitely conduct. Okay. So 0 less than T1 diode is on. Once the diode is on, the diode almost acts as short circuit. 2 volts input, output. And how the current flows? Current flows in anti-clockwise direction, anode to cathode of the diode. So I gave V capacitor polarities this way, but the capacitor is charging with polarities from right to left. We can take so that V capacitor will be negative. It means V capacitor is negative. Anyway, right, if you take the output equation, or we know V input is equal to V capacitor plus V output, in which V capacitor is equal to V in minus V output. Input is 5 sin omega t minus, what is our output here? 2 volts. Okay. Also, during the interval 0 to T1, input is less than 2. Means even though I am writing 5 sin omega t, 5 sin omega t value is less than 2. Ultimately, V capacitor is negative. No doubt about it. Okay. So, at t is equal to 0, if I take so, at t is equal to 0, the capacitor voltage will be minus 2 volts. Because input is 0 and V output is 2 volts. The diode is on 0 minus 2, it is minus 2. Next, suppose if I take this particular instant, here the input voltage may be 1 volt. Then V capacitor is equal to input minus V output, 1 minus 2, it is minus 1, it rises up to minus 1. At t is equal to T1, input is 2 and output is 2. So V capacitor is also is equal to 0 volts. It reaches 0. Okay, and 0 to T1, what is the output? If you observe the output from 0 to T1, it is simply 2 volts. Okay, this is fine. Next, for t greater than T1, input goes above 2 volts. Means the cathode voltage of the diode is trying to go above 2 volts. V capacitor is 0. Okay, V capacitor is 0 and for t greater than T1, input is going above 2 volts and cathode is going above 2 volts and anode is at 2, diode will be off. So for t greater than T1 or T1 less than T less than T2, the diode is off. So the equivalent circuit, if we take, it comes like this. The capacitor voltage is 0, means the capacitor simply acts as short circuit. Then what about output? Output is equal to input, T1 to T2. However, the input is rising, the same shape is followed by output, 0, T1 to T2. Okay, and what about the capacitor voltage? It is 0. Okay, next, for t greater than T2, what happens? T2 to 3t by 4 I can take from this point to this point. Okay, so input is less than 2 volts. means the cathode voltage of the diode is less than anode voltage. Diode is again on. Once the diode is on means the capacitor again starts charging towards a voltage given by input minus V reference. Okay. So T2 to 3T by 4. T2 less than T less than 3T by 4. Again the diode is on. As the diode is on, the equivalent circuit if we take, so again the capacitor starts charging with polarities this way. Okay, output is 2 volts, and if I take V capacitor this way, then again the same story repeats, that is V capacitor is equal to V in minus V output, 5 sin omega t minus 5, sorry, not 5, it is 2. It looks like 5 sin omega t minus 2, but the thing is 5 sin omega t value is less than 2 volts. Okay. So output is 2 volts from T2 to 3T by 4. Okay. So the capacitor rapidly charges towards input minus 2 with a time constant RF into C. We can write so. The capacitor rapidly charges towards V input minus 2 with time constant tau C is equal to RF into C. Sorry. Here I took ideal diode. If you take practical diode also, it is time constant is RF into C. It's very small value. Okay. We can take it. The capacitor is rapidly charging towards input voltage. Means it just follows the shape of the input. Whatever the shape we have for input from here to here, right? It will be following the same shape. Okay. Or what we can take is at this particular point T by 2, input is 0. Okay. Input is 0. Output is 2. So V capacitor is equal to 0 minus 2. It is equal to minus 2. So input is falling by 2 volts. Capacitor voltage also falls by 2 volts. That's what my concern is. Nothing else. Okay. This is the idea. So input is falling by 2, and because output is fixed, output is constant. Input falls by 2, capacitor voltage also falls by 2, almost. Next, input is further falling by another 5 volts, capacitor voltage also falls by 5 volts. So to what level it comes down, means it falls down up to minus 7 volts. So here to here it is 7 volts. Capacitor voltage falls up to 7 volts, minus 7 volts. Okay. So at T is equal to 3T by 4. So what is this value? Minus 2 means input is minus 5 and output is 2. Minus 5 minus 2, it is minus 7. Okay. During that time output is constant at 2 volts. The next point, at T is equal to 3T by 4 minus, I am writing, input value is minus 5 volt. Okay. Input comes down up to its a negative peak, and due to small delay, V capacitor is not exactly equal to minus 7. It may be minus 6.9 like that. V capacitor is equal to minus 6.9. Okay, done. For t greater than or at t is equal to 3t by 4 plus, input is slightly rising above its negative peak like this. At this particular instant, right, the input is rising above minus 5 volt. And V capacitor, by the time the capacitor reaches its right, minimum possible value, minus 7 volts. Okay. Then, okay, which implies V output is equal to V input minus V capacitor. It is equal to minus 4.9 minus of minus 7. It is equal to minus 2.1 volt. Okay, but also we know that V output is equal to Vd plus 2, which is equal to minus 2.1. Sorry, it is plus 2.1 volt. So minus 4.7 plus 7, it is 2.1 volt. So this value is equal to 2.1. So what is Vd from this? Vd is equal to 0.1, which is nothing but minus of anode to cathode voltage of the diode. See, Vd and voltage across the diode, even though I wrote Vd, anode to cathode voltage is equal to minus Vd. Okay, Vd is taken from cathode to anode, so anode to cathode will be obviously negative. VAC implies, right, VAC, anode to cathode voltage, is minus 0.1, for which the diode is immediately off. Anode to cathode voltage is negative, means immediately the diode becomes off. Once the diode is off, what is the equivalent circuit again? It is open circuit. 2 volts input and the capacitor V capacitor V output. So how does the capacitor charge? It charged to minus 7 volts, right? Anyway, it charged to 7 volts with polarities from right to left. Means V capacitor is equal to minus 7 volts. Now, is there any path for the capacitor either to charge nor to discharge? No, the capacitor can neither charge nor discharge. And acts as a DC source or a battery of value is equal to voltage is equal to V input minimum minus V reference. What is input minimum, friends? Minus 5 or negative peak. Minus 2. It is equal to minus 7 volts. Then what about the output equation then? V output is equal to input minus V capacitor. So implies V output is equal to input minus V capacitor. Input is 5 sin omega t minus V capacitor is minus 7. So what we can write? 5 sin omega t plus 7. We know also V output is equal to Vd plus 2. Is it not so? So which means what might be Vd? Vd is equal to 5 sin omega t plus 7 minus 2. It is 5 sin omega t plus 5. This equation doesn't change. Voltage across the diode does not change. And how do we write this waveform? 5 sin omega t plus 7. So how does it appear? In steady state, we know that with respect to 7 volts, 5 sin omega t signal appears. Is it not so? So anyway, right, if you do not have the reference voltage, what is the output we expect? 5 sin omega t plus 5. And what you are adding? 2 volts reference is added. That's the idea. That's what I wrote here directly, nothing else. Okay, so here the capacitor is neither charging nor discharging. It maintains that minus 7 volts forever. This way. So the capacitor charges from 2 to minus 5, a total of minus 7 volts across it. Okay, so once the diode is experiencing some negative voltage, it never conducts. For the diode to conduct again, input should fall below minus 5. Then only there is a scope for diode to conduct again, and to that peak the capacitor will charge. So from here onwards, what we can write, just if I take I will use another color here. Oh. T by 2, 3T by 4. So if you take your input waveform, it comes something like this. If all are in the same place, then it might be easier. So here 0 to T1 diode is on, and T2 to 3T by 4 diode is on. During that time output is 2 volts. Next, for T greater than 3T by 4, what is the output equation? It is given by 5 sin omega t plus 7. Okay, that is also fine, right? We can cross check that. From this point to this point, what happens, or this point you can take capital T. the input is rising by 5 and the capacitor is unable to change, unable to charge or discharge. So whatever the rise you have in input, that entire rise can be seen across the output terminals, 5 volts like this. And further means at t is equal to capital T, input is 0, output will be equal to 7 volts. That's the meaning of it. Next, at t is equal to 5t by 4, input is further rising by another 5, capacitor is unable to change its voltage, then output also will rise by the same amount. So input rises by 5 means output also rises by another 5 volt. 5t by 4. Further, input is falling by 5 at t is equal to 3t by 2. So input is 0, right? Capacitor voltage is minus 7, 0 minus of minus 7, it comes down up to plus 7 volt. Next, input is further falling by another 5 volts. Here capacitor voltage is minus 7, so minus 5 minus of minus 7, output falls down up to 0. Again it will rise and we can see like this, which means it is like a 5 sin omega t. What about this height? It is 5 volt. And what about this height? It is 5 volt. A 5 sin omega t signal is appearing with respect to 7 volts. That's the meaning. And this whole thing we can take it as the transient response. This is transient. Here also we can take this portion as transient. In steady state, the capacitor voltage is minus 7 volts. Output voltage is 5 sin omega t plus 7. This is what we can write. In steady state, V capacitor is equal to minus 7. Also, we can write it like it is V input minimum minus V reference, and output is equal to 5 sin omega t plus 7. It is generalizing it. It is like Vm sin omega t plus Vm plus V reference. That's it. This is how we can conclude the result. Okay, and again one more point I would like to mention. Students may be thinking like right, how it starts with a minus 2 capacitor voltage. Yes, once the diode is on, okay, rapidly the capacitor, so once the diode is on, the capacitor starts charging towards input minus V reference. So that is a 0, minus 2, minus 2. There is small delay, no doubt about it. Here we can see it is rapidly charging, not abrupt, rapidly it will charge. That delay will be there, no doubt about it, which I have not mentioned initially, but it is possible. So this is how we can analyze this positive clamper with reference voltage. Okay, and one more thing, if reference voltage is negative, what happens? The same positive clamper with reference voltage of minus 1 volt. Anything we can take, just I am writing here. So it is 5 sin omega t, V output, V capacitor, like this. So for the diode to conduct, input should be less than minus 1. Okay, instead of writing with respect to plus 2, earlier I have analyzed the circuit with respect to plus 2 volts. Okay, so instead of writing everything with respect to taking this line as +2, we should take -1. That's it. If input is less than -1, then the diode will conduct. And up to what level? -1 to -5. Okay. If input goes above -1 volt, diode cannot conduct. Input should be less than -1. Less than V reference, that's it. And to what level it will go? Means V input minimum minus V reference. Okay. So to that level, the capacitor will be charging. So here I am directly writing the statements like once the diode is on, capacitor charges up to input minimum minus V reference. What is input minimum, friends? -5. And what is V reference? It is -1. So it will go up to -4 volts. This is what we can see. So that the output is equal to input minus V capacitor. It is 5 sin omega t minus of -4. So the final answer is 5 sin omega t plus 4. Or alternatively, V output is equal to Vd plus V reference. What is our Vd? It is 5 sin omega t plus 5 and V reference is -1. Ultimately the same answer we are getting. Okay, that's it. This is how we can analyze it. If you want to see the transient response, the students can try, doesn't matter. Okay, here I am not doing it because I have given more than enough explanation for all these clamper circuits. That's it. Next point. If V reference is given, right? Okay, V reference may be positive or negative. This is how we are taking the analysis. And if V gamma is given, if V gamma is given as 0.7 volt, then the basic positive clamper circuit, it is Vm sin omega t. And what about the output? Right here, what is expected? Vm sin omega t plus Vm. In negative clamper, what we did? We added plus 0.7. Here we need to subtract. That's it. Because the capacitor will charge up to 0.7 volts with polarities from right to left. So instead of instead of negative peak, it will charge up to negative peak plus 0.7. Okay. So there it is plus and overall output it is minus. This is the idea. And one more thing, if you have some reference voltage, the same story, nothing to worry. So the output is equal to Vm sin omega t plus Vm minus 0.7 plus V reference. Okay, here one more point to be observed. In negative clampers, I told the positive peak of the input should be greater than V reference. If you recollect that point, if you take a negative clamper biased or with some reference voltage, it is Vm sin omega t. The positive peak should be greater than V reference, right? It may have something like this from 3 and all, right? Or 3 plus Vm sin omega t should be greater than V reference. Then only the diode will conduct. Then only we can take some output equations, right? And here what we said is positive peak of the input should be less than V reference, I told. Now instead of taking positive peak should be less than V reference, I should take here negative peak of the input should be less than V reference. then only the diode will conduct. Okay, so here note, the negative peak of the input should be less than V reference. Okay, so here it looks like V reference is positive, no issues. But here in the previous example, I mentioned -1. So if you observe this, this is our negative clamper, and it is suppose it is -6 volts and input is 5 sin omega t. Then what happens here? Is there any scope for the diode to conduct? Not at all. Even for the negative peak of the input, right, the cathode voltage is greater than anode voltage, so diode never conducts. Diode does not conduct and capacitor acts as short circuit. Okay, then what about output? V output is equal to input. That's it. So always, whether it's a positive clamper or negative clamper, the input is in such a way that there should be a scope for diode to conduct. Once the diode conducts, then the capacitor can charge. The remaining action can be taken accordingly. This is very, very important point. Okay, please do remember. The next thing, input may be a square wave. Doesn't matter, even for square wave also we can see that. Such a square wave is given to a positive clamper, assuming ideal diode. I am writing smaller diagrams, 5 -5 and input 0. What about the output? We know the diode conducts from T/2 to T. Instead of quarter cycle and all, it is half cycle. That too from what time to what time? T/2 to capital T. The diode will be on and the capacitor will rapidly charge towards -5 volts. So I can write here like T/2 less than T less than capital T, diode is on and capacitor rapidly charges. Towards -5 volt. So if you take V capacitor and V output, actually 0 to T/4, the diode doesn't conduct, capacitor voltage is 0. Okay, by that time output is equal to input, as the capacitor is acting as short circuit, it is 5 volt. This is what I can take from 0 to T/2, and T/2 to capital T, diode is on, diode acts as short circuit, almost it is 0, and V capacitor is rapidly charging up to -5 volt. Next, for T greater than capital T, the input is positive, diode becomes off. Once the diode is off, the capacitor can neither charge nor discharge, it holds that -5 volt forever. So once the diode is off, then whatever the variations you have in input, all those can be seen at the across the output. So input is rising up by, actually it rises from -5 to +5. 10 volts it is rising. The 10 volts rise you can see at the output. Right, and it is constant. Okay, constant means this is also constant. Next, input falls by 10 volts, output also falls by 10 volts. Okay, and the capacitor voltage is at -5 volt. it's not changing. Next input is minus 5. So capacitor voltage is minus 5. Minus 5 minus of minus 5. The output is simply 0. Next again it follows this way. Anyway, neglecting this transient, this is transient. In steady state, the capacitor voltage is minus 5 and output is a square wave with a peak amplitude of 10 volts. Maximum value of output is 10, minimum value is 0. Okay. If V gamma is given, then it further falls down by 0.7 volts. V reference is given. If V reference is positive, signal will be further going up, and if V reference is negative, signal further comes down. All such combinations we are aware. Okay, that's it. So here did I write the steady state waveform? We discussed all these things. Okay, steady state, what we can write here, I forgot. In steady state, V output, it is 2 volts, it is 5 plus 2 and it is 10 plus 2. This way. Okay. If V reference is minus 1, then comes down by an amount of V reference. The peak value is 9 volts and it is minus 5 volt. So what is the average value here? It is 4 volts. With respect to 4 volts, we can see the output waveform. Sorry, it's not minus 5. 4 minus 5, it is minus 1. V reference should come here. 0. Right. This is how we can take these waveforms. V reference and steady state. Anyway, we know. That's it. Okay. Next point. If you have reference voltage, then how do we do it? The same thing. Okay. So with the negative reference I am taking. See, in negative clamper I took this circuit, right? Some reference voltage we have. Then instead of reference voltage, I can write here a GNR diode, where Vz is equal to V reference. Okay, it is possible. The same way, positive clamper, I have to take a GNR diode whose direction is downwards. I can take a GNR diode whose direction is downwards. Here, you can't take the GNR diode downwards, because when it conducts, this will also conduct. And the capacitor voltage is equal to input minus 1.4, and that's what we can take. And once the diode is off, both are off, and there is no scope for this to undergo breakdown. Okay, for this to undergo breakdown, input should be a negative cycle, no doubt about it. during this negative cycle. But when it is negative, input is negative, diode D, ordinary diode, never conducts at all. Then even though you have the GNR diode, it does not play any role. Okay, so this is an invalid circuit. This circuit won't give the output according to our expectations. Suppose I want to have a negative reference voltage with negative clamper, and that too, that negative reference voltage in terms of the GNR diode, it is not possible. And again, in positive clamper, what I am doing, negative reference is possible. Okay, it is this will provide, once the GNR diode undergoes breakdown, definitely it will maintain a voltage Vz which is equal to V reference. Okay, students should observe this point also. V reference. Vz is equal to V reference. That's it. And more practical version means we can have the resistors as well. The first circuit means this one, and second circuit is that's it. Okay, with positive clamper, the diode and GNR diode, if you see, right, whether it's a positive or negative clamper, both should be in opposite directions. Okay, even to confuse us, they may show the GNR diode like this and ordinary diode upwards this way. Doesn't matter, both are in series, no, nothing to worry. Okay, even for negative clamper also, diode and GNR diode, right, they should be in opposite directions. They are in series, you can take ordinary diode first, next GNR diode, or vice versa. It is possible. That's it. So these are all the different combinations of clamper circuits. Even clippers also, we did ample amount of examples we discussed. Let us have a look at some problems on these clampers. The primary function of a clamper circuit is it introduces a DC level into a signal, right? It adds a DC. These are called as DC inserters or DC restorers. Second one, if the circuit shown has to function as a clamper circuit, which of the following conditions should be satisfied for sinusoidal signal of period capital T? The time constant should be large. It's a straightforward question. The input voltage is Vi is equal to 4 plus 3 sin omega t. Assuming all elements to be ideal, the average of the output voltage is, it is diode is downward, directed downward, it is a negative clamper, output is equal to Vm sin omega t minus Vm. So 3 sin omega t minus 3. In which this is AC component and this is DC component. So minus 3 volts is the DC value.